Hey, everybody. I'm Max. As I was so kindly introduced, I work at Capital One. Once upon a time, I was the chief architect of the Bugzilla project. And through basically improving developer experience, we took a small team of volunteers and we helped make that into, at the time, as far as we knew, the most popular enterprise bug tracking system in the world. I worked at Google, where I worked on code health and code review guidelines. I worked on, and then I was at LinkedIn, where I did a bunch of developer productivity stuff, including releasing a series of documents called the LinkedIn Developer Productivity and Happiness Framework, which describes sort of how to use data and feedback systems to understand your developers. And now I'm at Capital One, where I help lead the developer experience team. And I want to talk to you today about what are the core key principles of what makes a great developer experience. So I had about twice as many slides in this talk, and I ran through it, and it turns out it was like an hour, and unfortunately an hour doesn't fit into a 20-minute slot. Go figure. So I'm going to cover as much as I possibly can today, and I think you'll be surprised about how much of the actual key things, the most important things you need to know, you can cover in about 20, 25 minutes. So at the high level, when you're thinking about what a developer experience is directly, they're interacting with a tool, what are the things that you care about optimizing from a technical perspective, there's basically only 3 things that you need to optimize for. I've thought about what all the other things that we do, all the things that we care about in developer experience. There are things that we care about that aren't these 3 things, but they don't have to do directly with what does the developer experience. The things that we care about for what does the developer directly experience are basically these 3 things. I'm going to go over them today. So the first one, the first thing we're optimizing for is what we call cycle time. This is the time between when a developer has an intention and when they experience the result of that intention. And anytime you think about a cycle, the most important property you want to think about is the intention. So a lot of the time when people think about well, how would I measure this? The question you want to start with is the start point is when some person had some intention and then they realized the experience of that intention. There are large and small cycles. So this is basically like a fractal, like an image that no matter how much you zoom in, it looks like it's made of itself, right? And all large cycles are composed of smaller cycles. The smallest cycle would be I intend to write 1 line of code. And now I have written 1 line of code, there's the result. The largest cycle would be something like, I have observed a problem in the world and I would like to deliver a product to solve it. Now there is a product that people can use that they actively use and is successful and I have a business. That's the very big cycle, right? Now, when you talk about this with people, at first, they think, oh, great. So what we want to do is we want to speed up the big cycles, right? And, the bigger cycles are usually things like, I want to deliver a feature end to end. I have this thing that we're going to work on for 3 months. And what I, as an engineering leader, care about is I want to take that 3 months down to 2.5 months. And so what I do is I go to the team and I say, just go faster. Right? And obviously, this fixes all of their problems, right? I just go into a meeting and I say, everybody do the same exact thing you're doing now, but faster. Well, it turns out that doesn't work. What that results in is a decrease in quality in exchange for an increase in velocity. And a lot of the time, you don't even actually get the increase in velocity because the decrease in quality itself slows down the development team so much while they are developing that it ends up taking the same amount of time it would have taken if they didn't cut any corners. So what do you do? Well, as I said before, all large cycles are made up of smaller cycles. So let's say that we want to deliver a feature. We have a lot of tiny cycles inside of that. I have an idea. I need to go gather the requirements for just that specific idea. I need to write 1 PR for that specific idea. And now we're going to do a code review for that specific intent. And all of those are individual cycles. And whenever you really deeply investigate why a larger cycle takes time, it's always because something is wrong with one of the smaller cycles. Every single time. There is no time when it's oh, well, there's just something wrong with how we've structured the entire large cycle. It's always something like our code review process is slow. And you look into it, and it's usually like one of two things. By the way, it's almost always like one of two things. It's like individual responses take too long. Like the reviewer takes too long, and they take too long because they're doing something else. Like they're coding as a first priority, or they're in a meeting as a first priority, or they're doing support on Slack as a first priority instead of doing code reviews as the first priority before they start other work. Or they're like the PRs are too large or something like that. These are the things that you discover. And then you'll see other examples on the screen here of like small cycles that you might want to optimize if your large cycles are too slow. Now you'll notice the bottom one is about understanding failures, which is super common and brings us to an incredibly relevant point if we want to understand how to improve cycle time. All cycles that occur, whether they are large cycles or small cycles in a developer workflow, are a loop of observe, decide, and act. I make some observation, I receive some data, I make a decision based on that data, whether that data is like me looking at a thing or me reading something or me knowing something in my mind. And then I act based on that decision. And that's like in a large sense, I observe a problem in the world, I decide to make a solution, and we deliver a solution. That's the large one. And then the small one, I observe the last line of code that I wrote, I decide to write the next line of code, and then I write the next line of code. That's like a simple one. The slowest part of this cycle is almost always observe. The time to many people think, oh, I'm worried about how long developers take to actually type code into the IDE. That's not usually the slowest part. Usually the slowest part is, how do I gather the information I need in order to make the right decision? So think of it this way. Think of you have a test, and it fails in a dramatically confusing way. And now you're spending 20, 30 minutes trying to figure out what this test failure means, instead of just it telling you right away, here is the line of code, here is exactly what failed, here is why it failed. And you go, oh, I get it. And that takes almost no time. And then you go act on that information. One very common one that people sometimes overlook is having unclear requirements. If you don't know what your requirements are, it's very hard to make decisions. Bad error messages from tools cause long observation times. The key is to provide developers the information that they need at the moment that they need it, and no other information. You can also cause observation problems by flooding them with so much information that they can never possibly make a decision about it. If you want a safe rule for this, just think, how could I make it so that developers never have to think or guess about what their next step is? They should only have to look and understand something so they can make a decision. And this isn't because developers are stupid, it's because we care about them. We believe that they are intelligent people, but that doesn't mean we think that they should have to do a giant investigation on the universe to write one line of code. Okay, that's cycle time. The next one is what we call focus. Some people call it flow. Anybody who's done software development knows that it is an activity that requires deep focus for long periods of time. You are, the way that I describe it to people who are not programmers is I say you have this problem that you're solving, and you're building up a mind palace, and you're constantly telling yourself oh, don't forget about this thing that I got to solve in 5 minutes. And you've got 5 of those. Sometimes you're writing them down, but a lot of the time they're just sitting there in your mind, and you need to go through all of that as a consistent process as you're developing. And when you're doing this, and when you're just able to focus and you keep your attention on the task that you're doing, people refer to that as being in flow. When developers get interrupted or knocked out of flow, we call that context switching. You've probably heard this term. And the problem is your attention goes away, and if the attention shift is strong enough and for long enough, it breaks the mental structure that you were constructing, and you have to reconstruct it when you come back. It could take as long as 15 minutes to reconstruct it, from an interruption that takes as little as 30 seconds or 2 minutes, somewhere in there. There's varying research reports on this from all across time. The complexity of the interruption also matters. A very complex failure that you have to go and debug, even if it took you like 1.5 minutes or 2 minutes, is much more likely to break your focus than a message that shows up that like you ignore or is very easy and easy to understand. Even if like the solution for that takes 1.5 minutes, it didn't shift your attention off of your task. Surprisingly, another factor that really can break people's focus is something that's really emotional. So like if something just really, really irritates you while you're developing, it's much easier for that thing to break your focus because your attention goes on to your emotional interruption rather than the task that you're doing. Okay, so if you want to improve flow, there's a few questions that you can ask as a developer experience team. And the first one here is, do my tools force developers to engage in some complex task that isn't coding, testing, or debugging while they're doing those tasks? So imagine that you're deep in focus, you're doing a task, and you wanna push a build up to a testing system, and it tells you, sorry, you don't have permission. And that's the whole error message. And now you're like, how do I get permission? What permission do I need? Who do I ask? Is there a document? Does the search engine work? You're totally gonna be pulled out because of the complexity of the task. And then and as we've talked about in other talks here this time, are we ensuring that developers have multiple uninterrupted hours to focus on coding? So in a row. I'm gonna be more direct than other people have been in the past. You need to stop inviting frontline engineers to meetings. Like that needs to be the job of their manager or their tech lead. I have run successful large projects with almost no meetings entirely in asynchronous fashions. It can be done. It is a discipline that requires a lot of tooling that sometimes teams don't have, sort of a change in culture that teams don't have. But, look, there are situations that require meetings. There are legitimate situations that require you to have verbal conversations with other people, but it's not like the whole team needs to be there. In general, like the engineering manager should be, helping you do that, or the tech lead should be helping you sort of cover that so that the people who are expected to be coding most of the time can be coding most of the time. And now let's talk about the emotional one a little bit more, which is, do my tools, systems, or processes do something that's so frustrating to developers that it breaks their focus? Like, have you ever seen a tool just pause for a really long time with no output of any kind? And after a while, like, there's a certain period of where we were like, okay, it's fine. It's fine. It's fine. I'm gonna murder you. I'm gonna murder you. What's happening? If they produce more, as I talked before, if they produce more output than I could possibly read, I've seen build tools that just scroll my terminal, and I'm like, what am I gonna do with that? It just irritates me. And once again, confusing error messages actually cause me emotional frustration. Even if the developer can argue like, well, it's not that hard to figure it out. I'm like, yeah, but you upset me. And I know that sounds like a little soft, but it actually matters as far as focus goes. Another thing that people often miss is that if you don't understand why you're doing the task, who it's for, and what the intended result is, the thing that will break your focus is your own confusion. You will constantly sit there wondering, wait, how do I make this decision? Because I don't know why I'm doing this. If a developer doesn't understand why they're doing work, they will all constantly run into decision points that they have to make, like I could implement it this way or I could implement it that way. And they will just sit there being like, what am I supposed to do? Am I gonna go ask my tech lead? Should I ask my tech lead? And so having clarity actually dramatically improves developer experience. That is focus. Let's talk about cognitive load. I don't love this term because it's not clear to many people what it actually means. So what I care about here is, how much does a developer have to know in order to perform a task? And how many decisions is the developer forced to make when performing that task? Those are the two things that I care about. Now, when we talk about developers and upskilling people, obviously, we want developers to know as much as possible about what they are doing. Like, understanding assembly language does make you a better programmer, but you shouldn't have to know it to do most tasks. And you don't have to know it to do most tasks today in software engineering unless you are doing very low-level work. This is the key point that I'm making. We need to reduce what somebody has to know in order to perform a task successfully with high-quality results. Developer experience teams often fall down very, very hard here. They produce 10, 20, 30, 40, 50 tools that developers must all individually learn that are unique to the company. And the problem is this. Each tool developer thinks this is fine. Each tool developer is individually operating on their own tool. They say, I'm okay with developers spending 1 hour learning this tool because it's going to dramatically accelerate them in the future. The problem is there's 50 other people working on tools who all have the same thought. And if you're changing these tools enough, what you're asking for is something like 50, if there's 50 tools and they all require 1 hour a month to learn the changes or to learn something that has new behavior, you are asking for 50 hours a month from every developer just to understand how to work in your developer ecosystem. So one way to solve this is, you work on the user experience of the tools in a way that makes them intuitive, in a way that makes them behave like other tools that developers are already familiar with or other things that developers are already familiar with. But the better solution is to eliminate the need for the tool to exist at all. Let's say that you have a workflow for setting up alerts, and the workflow is like, first I write a configuration file, and then I run a tool to validate that configuration file. And then I run another tool to upload that configuration file to the right place so that it can be registered as an alert. And then if I want to make a change to it in the future, there's another tool for that. So one solution that a developer experience team could look at this and take is they could say, I'll just make all those tools really intuitive to use. But the better solution would be to do something like, how about I just check in the configuration file and the system does everything else for me automatically and I never have to use those other tools. Those other tools don't have to exist. I want to make a particular point. Some people think I can solve the problem by taking all 50 of my tools and putting them into one web UI. This solves the discoverability problem. It helps you know where all the tools are, but you still have 50 tools. It doesn't solve the cognitive load problem that developers have. You have to either make those tools more intuitive or delete them. Okay, now the most controversial thing in developer experience, and a thing that I am very, very convinced of after having worked in developer experience for a very long time, is the thing that it says on the screen here. It sounds controversial, but it is unquestionably true. Imagine that I have to, now let's take an absurd example. Imagine that I have to write a feature, just one feature that should take 1 day. But before I write that feature, I have to pick which cloud provider I'm going to deploy it to. I have to choose which programming language I'm going to write it in. I have to choose which build tool I'm going to use. I have to pick which UI framework I'm going to use. I have to argue with all my coworkers about tabs versus spaces. I have to pick a code review tool. I have to decide how to set up my own CI. I have to decide how my CI jobs are going to run. I have to decide my deployment patterns. That would be absurd, right? But on a smaller scale, we do this to developers all the time when we make them make choices about infrastructure that have nothing to do with the task they need to do. And look, I'm going to make a point. Most developers actually don't want to make these decisions. There is a loud minority that will come to you and be like, I need to be able to make every decision about my code base because I'm an extremely picky engineer. And I understand that. In my personal life, I love being able to choose everything that I use. But I'm not here just to accelerate one individual developer in a large company. I'm here to accelerate the business as a whole. And when you allow one developer to make decisions that potentially then slow down the company as a whole, you actually get net negative productivity for the company. And so there's two factors there. One of them is you can get net negative productivity. The other one is the majority of developers don't actually want to have to make every infrastructure choice in the world just to be able to write hello world. So when I say negative consequences, let's take one of the worst examples. If we let every individual developer pick whatever programming language they want to use, what this will eventually turn into is a giant set of unfunded mandates. Or a dramatic negative impact on other developers, either now or in the future. Individual developer loves Newlang. He loves Newlang. I understand. I'm a programming language nerd. I love lots of languages. But all the other developers on his team or the other developers in the larger team around him don't know Newlang. And then one day, the developer who loves Newlang leaves the company. Everybody's stuck with this code base. Nobody knows how to do it. I'm going to tell you a sad fact that I have observed many times. When that happens, those people labeled as other dev there will rewrite the entire thing. I don't think they should. I think maybe they should spend some time learning the new language and trying to incrementally refactor it. They never, ever do. They rewrite the whole thing. But the worst part is if you are a developer experience team, eventually, if this grows up from the ground and enough people start to adopt this Newlang without some sort of structured plan for how you're going to support it, eventually executives will show up at your door and be like, now you must deliver me tooling for Newlang. And you're going to be like, but I don't have people for Newlang. We didn't hire for that. There's no plan for that. And so this gets progressively more and more difficult. And then there's no good developer infrastructure for everybody who works in Newlang. They start to hate the developer experience team, even though there was no original agreement for the developer experience team to do this. Now, let me make a point here. There are many choices developers need to make that are very important to their ability to deliver business value and their own personal productivity and the team's productivity. So how do you know what's good and what's bad? You need to gather requirements. You need to really understand developers and learn what it is that they actually need to do based on what their real workflows are. Because it's very easy to also create overly restrictive systems that don't let people make the choices they need to make. And that can actually become one of the worst developer experience barriers in your company. So and then after you do that, once you've restricted choices, if you've provided a piece of infrastructure that has restricted people's choices, you need to continue to maintain that infrastructure because requirements will evolve over time. You cannot be like, well, we made it once and then we threw it over the wall and then we abandoned it, because over time it will start to restrict people's ability to do the things they need to do as the world evolves. So good restrictions are usually things like, we have a single CI system, because most people don't want to have to set up their own CI. That's not a good use of most product teams' time. There's exceptions, but mostly not. There is one monitoring and alerting system for the company, or there is one log storage system for production logs. Let me tell you, when you're in an incident, when you're trying to resolve a production incident in a complex microservice ecosystem, both of those things are going to help you a lot. But let me give you an example of a bad restriction. Let's say I was I've decided that the only language that anybody can ever use to write anything in is Python. Python's a fine language for the things that it's good at, but there are things that it's not the appropriate solution for. If I'm writing high-scale, low-level systems code, I don't want to write that in Python. And if I just mandated everybody has to use Python all the time, that would be a destructive mandate for the business. Or if I said everybody is only ever allowed to use a single editor, you should try sitting behind developers and watching how they work. And if you tell all the Emacs users that they can't use Emacs, you should actually see how much you will harm their productivity. It's quite wild. So the key is really about understanding developers and what their problems really are so that you can let them solve the problems they need to solve and you can solve the other problems that they don't need to solve. So to recap, these are the three things: cycle time, focus, and cognitive load. And they cover pretty much all of the principles at a high level that you need to care about for how to optimize a developer experience. So we know everything about developer experience now, right? Well, no, not quite. there's a whole other talk that I could give about what are the challenges of developer experience. What do you run into when you try to improve it in a business? And they're all essentially human problems, not technical problems. You know, there's how do you really understand your developers effectively so that you can prioritize and also deliver the right tools and systems to them? How do you deal with change aversion and managing change in a large organization? Because if you change something, people will be unhappy because you changed it. Not because there's something wrong with your change, but there's a certain amount of times when people are just going to be like, you change things, I don't like change, so I'm going to complain to you about the thing just because it's different. How do you ensure that you really provide leverage to the business? Like, how do you know that your investments in developer experience are actually providing more value than you're investing time, and how much more value they are investing time? One of the biggest ones that's most difficult is how do you say no to people when they come and ask you for things, especially if you try to work on improving developer experience. Everybody in the world is going to come and ask you for features and requests. And if you can't say no, you'll overwhelm the team to where they cannot deliver effectively anymore. So you have to like understand how to say no and what to say no to and how to prioritize on those things. And then one of the biggest ones is, how do you change a development culture? You know, how do you like win hearts and minds and like bridge the gap from how people behave today to like how we ideally think they should behave to be the most productive? I'd love to talk about all those in detail, but if you want to read about them, there is a full blog post that I read that is very long. It contains everything that I talked about today, plus all of the challenges that face developer experience teams and anybody who works on developer experience. And hopefully I will be able to do the talk on challenges maybe in a coming year at the summit. That's all I got. Thank you very much.